Okay, everybody, we'll go ahead and get started. Thank you for your patience. I appreciate it. We're a little bit over, and if you have to run off to get up to another class, don't worry about it. I'm good with that. So we'll have a recording here, so that's one of the advantages of doing this. As I look back at the Wednesday, we had finished up talking about RMC with the setup costs and all that business, with or without setup costs in that batch processing or that batch environment. And I wanted to make sure, I think we talked about Martin Beck. If not, I want to just take a quick look at it. And the Martin Beck is over on pages 332 to 336 in the textbook. We may have taken a look at that, but I want to just talk about it. Now, again, let me look for here for 330. Yep, we might have gotten to that point. All right. I think this is the RMC. So we looked at RMC and okay, yeah. Yeah. I just want to take a couple of minutes, and then what we'll do is we'll jump into the next module and we'll take a look at some of those. And then there's some materials there in the module, additional materials that I'd like you to take a look at. This, again, Martin Beck involves a distribution problem or a network problem. Now, when you look at this figure, this is over on page 332, 333, whatever, close to there, 334, pardon me. Again, in just some basics of networking. Number one, the circles are what we call a node. That's an arrival or an origin point. And then the arc are those lines between each of those, okay? And the arcs give us a cost per unit to transport to distribute the items, and they provide us those costs per unit. And so you're looking at Detroit sending something to Boston, it's 5 units, etc. And the whole point of this is to try to optimize this distribution system so that we take capacity, distribution routes, and demands and work that through so that we minimize the cost of doing so. Now, here they start at the bottom of the page and start to walk you through the variables that are represented, and they walk you through some of the notation there. And you'll notice, for example, you see X11, that's from node 1. That's going to be from origin node, okay, which is going to be Detroit to Boston. And then 1, 2, 1, 3, etc. Now, these, as I said before, these get terribly complex given the conditions on the arc. That's those lines from one node to the other. They get even more complicated if I have sub nodes or I have additional nodes interspersed between. And if you think of this for a moment, today FedEx, they never go to sleep, but this morning FedEx has got packages and things to deliver in Oklahoma City. They've got to deal with road problems, gridlock, construction. They have to have all of that planned out, and so they have their software is exceptionally sophisticated. They've probably got a team of 1,000 people that work with it. So the authors are trying just to show us a very simplistic picture here, and then to use the solver to come up with a way to minimize the cost of the distribution costs. And they walk us through some manual fixed costs, okay? And then, of course, the variable costs are going to be, the nodes will typically be a fixed cost, a plant, a distribution facility, a restaurant, in a retail outlet, or it could be an airport. That's a fixed cost. The variable costs that are part of the total cost picture are the transportation costs. That's going to be fuel, someone to operate something, the time spent unloading, loading, etc. So they're balancing, and the old familiar total cost equation comes into play as we look at fixed costs, variable costs equal total cost, and it's the same as we see that here in this case. So the authors are walking through this. Now, in this case, they're talking about the 0-1 variables. They're talking about that basic choice, okay, a go or no go type of choice. And we did the same thing when we worked binary, when we worked with the capital budgeting. Now, as I've said before, I don't believe in binary choices. I believe that if you've done your homework, you'll see you have a variety of alternatives you could follow, as well as a variety of outcomes. So if you put together a portfolio, same issue, I'd say you really do have almost an infinite set of choices if you can put as much or as little you want into any given asset, and then you have almost an infinite variety of outcomes. It's just, now you might have history to guide you, etc., but for all intents and purposes, the binary choice is somewhat of an illusion, although you make a decision and you go with it. So they walk us through that process there, and they start to look at the capacities for each of these nodes. Okay? And there at the very bottom, I think this is now page 335. At the very bottom of 335, you see the mathematical model. Okay? This is the minimization. This is the objective. And as we started the course and we talked about the use of models, I can't express to you, and this is why I say it every single time we meet, I can't express to you what an important change that is for us in how we do business. And this has occurred primarily because of challenges that we faced. Management science has really taken off because of the challenges we faced in the Second World War, and today the challenges we face in dealing with the global economy. You have to be able to try to find the optimal, or as get close to optimality on your operations as possible. If you don't, you are at a disadvantage. And that goes from getting the package for the cheapest to a customer. If you think about it like this, you look at, let's say you order something online, you can pay a premium to have it delivered quickly, or you can take it for the standard delivery. And again, if you can drop that price or that cost down, you might have an advantage. So you sell some books at one, let's say Amazon can sell you the same books for $5 or $6 less than Barnes and Noble, and that's on a shipping cost. And you might say, okay, well, I'll go that. Or if you're buying some type of equipment from distributors, and you'll probably, if you're a long-term customer, you'll probably kind of have what you would call, I call a back office e-commerce store, a B2B store, and you'll order what you need to get, and you'll get a deal. And if your vendor is offering just a straight price, but you can go to another vendor, and you can get terms like a 2-10-30. So you get 2% off if you pay the full amount due in 10 days, or you can pay the full amount in 30 days. You get that 2% trade credit. That can really make the difference. And you can go out on the internet and take a look at what the advantage of using trade credits. I think I saw one time, I don't know, one example where the people could borrow the money is the purchaser could borrow the money at like 25% annually, and with taking the 2% trade credit, they came out like gangbusters. Of course, if you don't have to do that in your cash, you have the cash or the credit line to accomplish that goal, you're in good shape. So having this model gives us a tremendous advantage from what we did in the past. And it's important also for you to understand that the practice of business administration, a business run by somebody other than the owner, the concept of producing on a mass scale, these are relative, in historic terms, are relatively new things. It was only at the start of the 20th century that we started making things in mass distribution. Of course, you've heard about Henry Ford and this assembly line in the Model T. Up to that point, businesses were usually a small entrepreneurial effort, usually a family kind of affair, and the people who owned it ran it. Now we live in an era where the people own it, don't run it. They hire people to run it for them. That's you and me. So being able to put the model together lets us look at alternative outcomes or possible alternative outcomes based upon what might occur. So we can model those things and we can look at them. And so we see this, we're going to minimize those shipping costs, and then we see it's subject to the following constraints. And there are the constraints in terms of the capacity of each of those outlets, those locations. This is on 335. It's far more important for you to understand the meaning of what we're doing and to get and understand that this is a way of thinking as opposed to just using a herring blender and putting stuff in it and run it. That's Excel, put in Solver. Or, as this course used to be taught, every single case make you do algebraic equations and chart it on graph paper. If you don't get the understanding, it's just like statistics. If you don't get statistical reasoning, the course is wasted on you. Okay? And that statistical reasoning is about probabilities, usually about the Gaussian distribution and how those probabilities fall. You know, the one standard deviation above the mean, one standard deviation below the mean, etc. The same story here. We can imagine what will this look like if we change those capacities. Now we've set up the capacities based upon what we know to be Detroit's capacity, Toledo, etc. Okay? Now if I was looking at that and I was doing this for real, the first thing I'd say is there any way I can change the capacity of each of those? Is it possible for me, by changing the capacity of each of those units, to change what it's going to take for me can I run everything through one place? Could I find a hub of some sort or a couple of hubs other than each of these one-shot deals? Okay. Part of the cost that's involved here also is if you go back, let's just go back for a second and go back on the page. As the authors have shown them, they're showing us a pretty devastating set of arcs. You say, what do you mean? Notice that the arcs have one arrowhead. That means these are one-way shots. So I'm either paying somebody to deliver this stuff for me. I have an outside vendor, so I'm dependent upon them. And if you've taken your policy course or the intro to management, you learned, if you studied the Porter model, you understood that one of the key things about a company and its viability is its power relative to its suppliers. So if you've got a vendor who takes this stuff for you, you're at their mercy. The other problem is you say, well, let's do a make buy and see if we can have our own trucking fleet. Then you got to figure out that cost. But this is not a great situation because everything is moving left to right. Everything is one way. So you have the problem of a deadhead. That is, I take stuff and I deliver it, and then I come back empty. And you know, if you're driving a truck, if you're an independent owner of a truck, or you're driving for any firm like J.B. Hunt, deadheads are your nightmare because you're on the road with nothing in the truck, and every second you're doing that, you're wasting time and money. So you want to handle things such that you have some way that you have a reason to go there and then return or go to somewhere else. So you're always carrying something. You always have goods in movement. If you don't have goods, you don't have any movement. And the distribution centers themselves, one of the questions, this is all I know, beyond beyond the textbook, okay? But one of the reasons I'm here is because I've lived some of this stuff. If I could take those distribution centers and I can increase their capacity by 10%, I built some Slack resources. And that might be configuration of inbound. That is the place where we accept the stuff they send us. That might be in terms of reconfiguring the storage areas. It might be an issue of packaging. Who knows? And there are folks out there who are, they're called industrial engineers, who can go in and take a look at a facility and go, we can improve this facility by 20 or 30% in terms of its real capacity. Now, I don't know how many of you took the production course, and I'm not sure what you got in that course, but you always should remember, if you didn't hear this, there's two kinds of capacity. One is the theoretical capacity, and the other is the real or actual capacity, okay? Theoretically, this lab, for example, has a certain number of machines, so we could put a certain number of students in here. That's the theoretical capacity. But on any given day, if 2, 3, 4, or 5 of them, or how many ever, are not operating, then my real capacity is what? The number of machines less the ones I can't use. That's the real capacity. And that's something that we have to think of our way through. So you'd want to make sure that you have those distribution centers, those capacities that you if you have it, you would need to take a look to see, do I have the best capacity I can possibly get? When I was at Webster University, I was getting my second and third masters. I took 2 tracks. One was finance and the other was operations. I worked for a university that was operating campuses all across the country, and space was critical. What we do is we'd go in and create a building with signage and then rent out the rest of the building and use a piece of the building for our campus. They served working adults, so they had a lot of night and weekend classes, that type of thing. And as we started to look around, we began to realize, we're not using our space very effectively. So for my thesis, basically what I did really wasn't a thesis, it was more like a project kind of thing. I went to look, and I found vendors who supplied desks. And these are like conference setting kinds of things. And we found a vendor who could help us configure our rooms in about 6 different ways. And so we really were able to expand our capacity. Our choice was, for example, in St. Louis, we had about, maybe 1,400 students. And our choice was that we could bring them into our campus. And if we didn't have the capacity on a given night, then we had to have them out somewhere else. We had an education program, they'd meet at the schools, everybody was fine with that. But we had business people, so we'd have to go rent conference space or go try and get somebody who was in our neighborhood, in our complex, to let us use one floor of their building, and it was a mess. So that was a key challenge for us. So what we came up with is we found a way to increase our capacity by just simply the configuration of our desks. And we were able to increase it by about 20%. And at that point, we were coming in there. You said, well, what's the big deal about that? Well, the big deal about that was this. If you're getting a degree from a school that's headquartered in Chicago and you're in St. Louis, you're naturally skeptical. Are these people for real, et cetera? So we've tried at each one of our campuses to have a full campus system there available till about 8 o'clock at night, because there's students that come in at 6 after work, et cetera. So just that one thing really was a game changer for us in terms of the amount of work that we could do with our students. So this is important stuff, and I think it's exciting stuff because you really can make an impact. But this ability, again, for us to come and model this is exceptionally important. Then, of course, we see the solution, okay? And from the objective function, the optimal value, and we see each of the variables, the values for them, and we've talked some about the notation. And then we go looking for any slack or surplus resources and the constraints. You with me? You're going to hear me harp about this, but if you were to ask me, you say, Dr. Harmon, 25 years down the road, if you were to say, what will be the most valuable companies on Wall Street? I'm going to tell you what they will be. At least half of them are going to be logistics and distribution companies. Why? Because as global trade grows, you're going to have to be able to get it from point A to point B. I don't care if you're e-tailing or you're retailing, you've got to be able to move goods and do so efficiently. And what will happen is as the global economy expands, you'll have a lot of people enter that business. And eventually what will happen, like it does in most industries, you'll have somewhere between a half a dozen or a dozen or so to become the big dogs in that industry. So there are great opportunities out there for you if you choose to go that route and take a look at that as a career. And I strongly, strongly encourage you. When I taught the policy course, it used to just give me heartburn when I'd say, how many of you have a job or a line on a job? And I'd see 6 hands out of 30 people. I'd be going, well, we have a practicum, we have an interim. Maybe we don't coach many of you well enough to go out. And interestingly, how many of you went to the forum the other day? Did you see the show of hands when they said, how many of you want to own your own business? And the hands all shot up. I thought that was interesting, and it was very encouraging to me. And I'm going to tell you why. Small businesses, entrepreneurial firms, right now, interestingly enough, run by women, are the engine of our economy. That's where we're getting new jobs. So if you think you'd like to do that, hey, I would encourage you, go into it with your eyes open. Go into it understanding the risks. If you were to come to me and say, well, okay, how would I get started? I'd say, number one, I think we have some courses here. Number two, I'd say this, go to work for the most successful, largest retail franchise operation you can find. Because if you stick with them, you'll learn the secret of their success. And eventually, if you accumulate a little bit of wealth or you get a good reputation, you may fall into a deal where they might say, hey, we've got a couple of underperforming units. We'll let you have them if you want them. My dad, that's how he got into the grocery business. He worked for a company called Fleming Company, which is at the time, I think the 3rd or 4th largest wholesaler in the country. And my dad had never finished high school, but he was one of these remarkable people. He just had this brain. He wasn't a normal human being. And unfortunately for me, I didn't inherit any of it, but he became their location manager. He'd find locations and he became the fixer. That is, if they had a store that was dying, he'd go out and fix the store. And he hit a ceiling because he said, you don't have a high school education, much less a college education, so we really can't advance you. He said, well, how about if you give me some stores, and if I save them, will you let me have them? So he had 4 stores, and these are run what was called the IGA concept, where you'd have a person whose name was on it like a fan, and then you had so it didn't look like it was a big chain like Safeway or something like that. It looked, I'm the local friendly grocer, which was not true. Fleming had a whole program they ran on how to run the stores, how to operate them, and they would set people up in business on a consignment of goods process. And that means I'll give you 6 months of groceries and meat, etc. I'll be your sole supplier. This is a loan. And if you turn a profit, we'll keep you going. If you don't, we'll find someone to come in and take the place. And so he got the stores and he did some refurbishing and did his magic, and poof, away he went. So I was encouraged when I saw the hands that went up. So yeah, I'd like to. I'd say if you're If your family has a business, if you can work into a continuity situation, do so. If you really want to do that, then go to work for people, especially those who have franchised, who've been successful, who will put you through their school. Now, there's some places, like McDonald's or folks like that, will say, okay, if you've got $1 million and you'll go to our McDonald's University for a year, we'll try you out as a franchisee. Those folks are pretty ruthless, because if you don't produce, they get rid of you. We were at lunch yesterday, and a young man came by our table, and the usual thing, how was the food and all that. And I began to talk to him. And as he began to find out what's going on with you in your career, where you're going, etc., he was telling me about that restaurant chain and that they had a great management path for him. And he said, I'm on the path to owning my own store, or at least being partners with the holding company that owns that set of outlets. I think good for you. So I hope if that's really something that you want to do, you'll pursue it. Small business is the engine of growth in our country. These big multinational corporations, they're not going anywhere. They're just going to sit there and keep cutting people and trying to use economy and scale to their advantage. But if you really want to get in on some action, small businesses are really where it's at. Okay, enough of that sermon. I should take up a collection. Now, they, in this problem, they show us this region over here, and they're moving us into this bank location problem. Okay. Now, the files for Martin Beck, as is the case for RMC and ICE Code, those are all over in the Anderson files in those chapters, and all you have to do is really just pop those out of there and upload them. Now let's see if I had us do anything. I'm trying to recall if I asked us to do something. No, because I felt like the text and had given us what we needed. Those are due on the 15th. Anybody have a question I could try to answer for you about what we talked about? I hope it makes you think. I truly do. Because it is indeed a thought process. Let's look ahead a little bit and go over that to the modules. And here we go. And let's pop ahead now. Next week, of course, is spring break, so we don't have any classes. Okay, and then we'll start to look at module 7. Now, one of the textbooks for our course is this textbook called Data Smart. Okay, and let me go over here to Vital Source and find it for you so you have it. If you haven't gotten it, you should. Here it is. This is the one with the guy upside down. It says Data Smart. The author of this textbook, I think he still is there, was the CIO of a company that, MailChimp. It's a company that works with other businesses in helping them deal with spam and email clutter. And if you're like me, you face the music every morning and you go, what do I keep? What do I get rid of? I've got 53 things. I should just file them. It's maddening. So MailChimp provides a service where they can filter for folks unnecessary and unwanted email. Okay? So he's their CIO. That's their business model, and that's what they do. Now, the guy is, as you read this book, you're going to find he's a young guy. He's exceptionally intelligent. He's scary smart. And what he's done is he's put together a series of cases for us where he just uses Excel and he performs some big data operations. I've never seen anybody, the only person I've ever seen who he would rival in their ability to use Excel would be Dr. Flint, who used to be here. Dr. Flint was incredible with Excel. blew me away. But Dr. Flint was a savant. He took Python with Dr. Marimi. And I remember I walked in there one day and Dr. Marimi was asking him questions about Python. I thought, whoa. But he had a gift for language. This guy has done an enormously cool thing, taking Excel and using it in a series of cases to show us how we can use big data. Now, there are, as someone who, I went through a program through Johns Hopkins, okay, in data science. And R programming is a wonderful programming language to learn, but it's open source, which means it's constantly changing. You don't have control over it, but it's meant to handle large numbers of data and help you clean them and help you arrange them into a tabular form. When folks talk about big data, one of the big issues they have is the so-called unstructured data, and how do we clean it up and get it in tabular form so we can use it. So this textbook is going to start us off on a series of cases where we work with them. And the first is going to be one, if you're a marketing major, it ought to be of interest to you. This is going to be cluster analysis. Now, it's the Foreman files. Those Foreman student files are over here in Canvas. You can also go to the book website, but I've got them here in Canvas for you to see, and we're going to start working through them. And that first one is going to be cluster analysis. Now, one of the interesting things you're going to see is that he uses a management science approach, because in every single one of these applications that he develops, he's going to use some theory from the hard sciences. And I got to tell you something. You know, when I read, every time I look at his text, I want to go, I am not worthy. I am not worthy. Okay? Like Beavis and Butthead. I am not worthy. Because it's incredible. And so when you see this, I go, wow, there are people out there taking all these courses using R, or they're using Python and trying to clean data. And this guy is just he's taking Excel. Now, Excel has some limits in terms of its capacities, okay, and that's an issue. But this is a piece of management science that's happening. All of you who are at Forum, did you hear the speakers as they talked about technology? And that spreadsheeting was not good enough anymore? This is what they're talking about. The ability to use all of these different applications. One of them, and I didn't ask the question because I didn't want to prolong your agony, but I'm curious about if any of them are using locational analysis. I doubt they're using any of these new tools that are out here that do spatial analysis, but I can guarantee you that they're using some tools, they're using some analytics tools dealing with big data. And so if you listen to them, they were telling you exactly what I'm telling you. Spreadsheeting is great, but it ain't enough. Now, what this guy's done in his book, Smart Data, is he has taken Excel and said, I'm going to push it to its limits, and I'm going to mix and match and use its functions in a highly creative way. And so that's why I use the text. And I think it's good for you to see and understand when you hear about unstructured data or big data. Maybe you've taken a course. I think one of the other voices here, I think maybe, is Dr. Green, who talks about it. I think we're probably the only ones who are badgering all of you to be thinking about this, learn about this all that you can. 90%, 95% of the effort in working with big data is this: it's unstructured, so you have to clean it up. The other part of analyzing it, that's the easy part. And I learned what a challenging and yet potentially fruitful kind of thing this is when I went to the set of courses I did, as Johns Hopkins offered it. I was working with data that were not primarily business data, but I think in one case we had, I think, 300,000 records, and the records had been created over a series of 25 years, and they were in all different types of formats and all that. And so we had to take a couple of the functions that R uses and melt those parameters down and put those data in the columns that we wanted based upon the type of data they were. At that point, my eyes were bugging out of my head. I was having fire blowing out of my ears, and I was taking it home. It was it was a MOOC, and I told my wife, I said, I've just seen the future, and it scares me to death. And I just realized I'm coming close to obsolescence. And she laughed, and I looked at it. But do I have any finance majors in here? I had a conversation with a couple of faculty this week. I like to go out and look at monster.com specifically to see what are they after. For example, a financial analyst, a starting position. What skill sets are they looking for? As I looked, I keep seeing knowledge of R, ability to work in Python. I thought all I needed to know was time value, the time value of money, and maybe a few Excel things to do some annuities, and I'm good to go. And I'm sitting here going, doesn't look like that to me. This is the same thing that happened to marketing. I first came here about, when I was here 12 years ago, marketing was just changing dramatically. And so, did any of you take Dr. Green's digital advertising course? Oh my goodness. Are any marketing majors in here? Okay. Boy, he offered in J-term. If you get a chance, you need to go visit with him about that. Or if you're leaving, fine. But if you get a chance even to come back and audit that course, or you can take it somewhere else, you really need to. If you go out there today, now if you're dealing with logistics and that kind of thing, it's one thing. But if you go into an advertising boutique or a PR boutique and you don't have those skills, you may not get the job. You may not even get an interview. I don't know. I think there's someone in here. You are, right? You're doing some digital, social media work and digital. Am I lying to everybody or not? Am I telling the truth? Yeah. And so I want you to know that social media, there's, if I'm a company, I want to know, what are people saying about my products? What types of people come into my website, my Facebook page or Twitter? What do people say about me on Twitter? All of that out there is just this vast, untapped bunch of stuff. And at first, I was one of those people who said, well, okay, it's a messaging service. And then one day I realized that Kim Kardashian, did anybody know how many followers Kim Kardashian has on Twitter? Like 1 million, 2 million, 5 million? And I realized the light bulb went on my head and said, those are eyeballs. And advertisers like eyeballs. So, and I think either her or the infamous Paris Hilton were the first people who were celebrities because they were celebrities. They didn't really do anything. They weren't athletes, they weren't performers. Well, one, but naughty. But I'm famous because I'm famous. I think, okay. Wow. All right. So there's a couple of cases that we're going to look at there that week. And we're going to look, first of all, at cluster analysis. This is going to be a very, very fascinating look at a company that sells wine. I knew you'd all get off on that. So I can give you a little tease there. Talk about wine. Okay. You guys are too mature for that. You're already buying it illegally, so I won't say any more. But this is a company that runs specials on different types of wine at different types of the year. And they're going to try to figure out, are there some clusters of people who purchase certain groups of wines or sets of wine together so I can identify a market segment. So that's just fantastic stuff. And he provides you an excellent narrative through the textbook. He provides you the files to take a look at and work with. So he basically gives you a template. If you're a marketing student, I think you'll really want to be taking a look at. Then he's got Par Nonlinear, and that's, again, this is one of our Anderson text cases where we start to look at data that don't meet the simplex LP model. So we're kind of moving away and branching from that. Make sense? Again, now you'll also want to take a look at all the resources I have there for you, okay? And I've got some resources about spam, a little bit about MailChimp, the Vroni diagram, which is a model out of science that is utilized for us to try to determine distance and clusters. Cluster analysis is also used in spatial location analysis. And it shouldn't surprise us that people with certain economic and social backgrounds tend to live in the same place. People tend to cluster together, which shouldn't surprise us, but seems that we do that all the time. And we also have, I have some information there for you, or a little bit of a blurb on concave versus convex functions. So as we move away from a straight linear or LP model, we start to look at those concave and convex functions like marginal revenue, like marginal cost, utility, marginal utility. You'll want to take a look at that. Then some economic models of nonlinear functions. I want you to take a look at some of those. Some of the, this is a SAS and STAT, their software cluster analysis. There's tremendous tools. I've probably shared this with you before. We have an advisory council who sits down with the dean once or twice a year, and they tell the dean what we're not doing, what we should be teaching. And it's always someone will say, well, we should be teaching this software or that software. And so I hear about it, and I go, well, you know, we cover pretty much the basics, because the truth is there are probably 50 of those products out there. I could spend 3 semesters with you if you wanted to learn every single product, and you might go to work for somebody that uses 2 of them. Then the JPM software, and we'll be looking at the offset function, which is kind of an interesting one. And I have an easy Excel tutorial for you for that. And then these are some of my notes related to distances and silhouettes that we use in that cluster analysis. And then we're going to be working what's called k-means clustering and how we determine, okay, the number of clusters that we want to try to define or use. So that's what we've got coming up after the after spring break. And I would encourage you, of course, don't forget the stuff that's due this week, but start taking a look ahead, because you're going to see some pretty interesting and creative and challenging stuff there that will give you a leg up when you go out to interview. And you know, someone said, have you ever done any work with unstructured data or looked a little bit at large data, big data? You can say, yes, you have, because you're going to get the exposure here. And if you've had some exams with me, particularly BISS 1123, I did precisely that in 1 or 2 of those exams. I think also in the data admin course, which needs to be revamped about every 3 months. Well, folks, thank you so much for your time. And I got started late. I apologize. And on Wednesday, I'll try to make up for some of the time. But God bless you. Thank you for being here. And I'll see you online Wednesday.